So previously we talked a lot about robots and robotic foundation models, that is the brains of the robots.
Mm.
So this is one of the videos which is sort of a very mini documentary, and it also includes the interview with a company named Physical Intelligence. So they're building a robot foundation model. So that is basically the foundation model for robots. So I had previously heard of this, but I haven't gone deep into this company. So this is going to be first time for me too. So
Mm.
let's just take a look at what they have.
This is a fully autonomous coffee making robot. And this is Lockie Grimm, one of the co-founders behind the company who created it. We flew to San Francisco to find out how the physical intelligence team planned to create the world's first intelligent robot brains. And we sat down with Lockie to discuss what a robot future could actually look like.
It's like somewhat unimaginable how different the world could look.
We also wanted to speak to the brains behind the operation who've helped secure $1.1 billion in fundraising.
How does an Australian from Perth end up as the co-founder of one of the hottest companies in the world right now?
That was,
But before any of that future can happen, there's one problem that stopped every robotics company before them.
we don't exactly know how to solve it. We have a bunch of theories on how to make progress, and that's what we do here.
We're in San Francisco right now, about to interview one of the hottest companies in the world, Physical Intelligence, that's building AI brains for robots.
Yeah, we're about to do an exclusive interview with the Australian enigma Lockie Groom. He came over to Valley over 10 years ago and is building this company that is at the forefront of building software for robotics.
Yeah, other robotics companies have got demos in action, but they don't adapt to the real world. And Physical Intelligence has this huge idea to make a foundation model that adapts to the real world, and we're going to actually see it in action today. And if what they do works, the future could be profoundly different. And we're going to ask them the question, what does the world look like in 10 years?
Yeah, but I think the big question is, can we actually get these robots to work? We're not sure yet. Everybody's been trying to do this for decades. Let's go inside.
Cool.
However, before we tour the office, I want to pose you a question. Why is it that robots have been able to beat the greatest chess players in history, and yet, whenever they try to walk, they struggle to stand their feet? Today, we came to investigate the big question that has stumped robotics since its inception in the 1950s. In 1988, a robotics researcher named Hans Marovec noticed a persistent issue that he and his colleagues faced. Hans wrote that it is comparatively easy to make computers exhibit adult-level performance on intelligence tests or playing checkers, and difficult or impossible to give them the skills of a one-year-old when it comes to perception and mobility. Nearly 40 years later, Marovec's paradox still remains the biggest hurdle that's facing robotics today. However, as you're about to see, Lockie Groom and his team might be on the cusp of solving it once and for all.
Ricky, nice to meet you.
Nice to meet you too.
Ricky?
Good to see you. How you doing?
I'm good. How about you guys?
Good.
Yeah.
I'm excited to have a little tour around here.
Yeah, of course. Yeah, it's actually usually like this. So we have people data collecting over here.
Yeah.
We actually have our cafe over here, actually. If you guys want to order coffee, do you guys want to order any
Would
coffee?
love a coffee.
Yeah.
Let's do it. Is an iced latte on the menu?
It is, yeah. Charlie.
Cool, let's get an iced latte.
Coming right up.
Yeah.
And this is like one of the tasks that I actually have prototyped before.
The coffee.
The coffee, yeah. So since day one, like I've seen this like robot like struggle in making coffee. Like it couldn't even insert the pour filter.
Yeah.
But now it's able to make a like full on like drink.
Best robot coffee I've ever had. Thank you, guys.
Awesome.
Thank you, robot.
Do you wanna show us what's going on here? Because this is really cool.
Yeah.
I'm like very, very bad at folding my laundry, so I feel like
I don't think
me
it
too,
actually
me too.
even does laundry at all. So this is helpful for him.
Yeah.
Yeah, so basically the robot is doing this autonomously, and so it's like trying to kind of like solve this like solution of like how do I approach this, like never just seen before shorts, and how do I fold this, that.
And then when it learns how to fold this, then when it sees these kinds of shorts again, I'll be able to do it.
Yeah.
Yeah.
I think like just repetitiveness, just like humans, like more repetition will like definitely like help.
How much?
So we definitely do have like much more tasks other than like coffee and laundry.
Yeah.
If we go over here,
Yeah.
you can see that like someone is like
Just,
peeling fruits, you know.
Wow.
Is this like trying to teach the robot how to do it through
Yeah.
a human do it? Okay.
Yeah, basically, yeah.
And
So-
then if it's successful, you collect the data and you can put that into code?
yeah, exactly.
Okay. Really quick, if you want more behind the scenes looks into these tech startups, please hit the subscribe button. We spend a lot of time trying to get access into these companies, and your support means that we can make more of these. Thanks. What we were seeing in the physical intelligence lab looked impressive, but it didn't explain why robotics has struggled in the real world for decades.
You said that like robotics has kind of overpromised and underdelivered in the past, right? All of us have seen demos of robots doing backflips and doing really interesting things. But the reason we don't have robots around all the time is because a lot of these demos are in constrained environments. How is the work that physical intelligence is doing trying to kind of solve that constraint problem?
So it's not just constrained environments, it's that the previous era of robotics was almost entirely scripted. And there's nothing wrong with scripted robotics. You know, it's not misleading, it's not a lie. It's just that most robotic deployments were entirely deterministic. You know, you deploy them into a factory, it picks up the same object in the same location, it manipulates it in the same way, it moves on to the next thing. And then this next wave of robotics had some amount of, I don't know, computer vision augmentation to it. It could do things that were not exactly pre-programmed, but it was a certain set of scenarios. But it's still extremely constrained. And so the environments either need to be constrained, the use case is constrained, but really it's the variability needs to be constrained. Yeah. The world that we operate in is not at all constrained. The messes in our kitchens are not at all constrained. That requires some amount of intelligence to operate in. And we just, that has been an unsolved problem. What's been easy for computers to solve is the things that are hard for us. You know, it's like arithmetic, reasoning. And what's been very hard for computers is what's trivial for us: walking, driving, learning to play video games. And that's what we refer to as physical intelligence. And what's really been missing is physical intelligence, is the brain that can operate these robots. And so that's what the entire company is focused on, is solving this problem of physical intelligence. We don't exactly know how to solve it. We have a bunch of theories on how to make progress, and that's what we do here.
We also spoke to Philip Clark of Thrive, who's among one of the first investors to invest in physical intelligence.
I'm Philip. I am one of the investment partners at Thrive Capital. Physical intelligence is an investment that my partner Josh and I led the seed and Series A round into back originally in March of 2024 and then again in September of 2024. So we've been investors in the company basically since it was 4 people in a living room, and have the privilege of seeing it grow up into something that is the now Frontier Robotics AI Research Lab.
We wanted to know what made Lockie Groom and physical intelligence such an appealing investment for Thrive.
Every great company investment comes down to 2 things, which is people and timing. Very clear that these are the very best researchers in the world going after this problem. I don't think anyone would dispute that. Timing, I think, is the other aspect here that's really important, because you're right. I think if we wound back the clock 10, 20 years, this would be a really hard company to build because the underlying technology capabilities, the model capabilities just weren't there.
Trying to solve a problem this big raises an obvious question. Who would even take it on?
Pulling it back for a second, how does an Australian from Perth end up as the co-founder of one of the hottest companies in the world right now?
You get on a plane when you're 17, you fly out here, you join Stripe. I was at Stripe for 6 years, been investing for the past 5 years. I've always been somewhat obsessed with robotics and frankly somewhat disappointed with how little progress we've made in robotics. It feels like we've made so much progress on the internet, on software, and so little progress on technology in the physical world. And so starting in 2021, 2022, I started seeing some really incredible papers come out of Sergey Levin's lab and Chelsea Finn's lab, and started just following everything that came out. Yeah. And I mentioned to a handful of friends, if you ever hear of them thinking of starting something, let me know. And in 2023, a friend of mine let me know that he was hearing rumors, like maybe they're thinking of starting something. So at that point, I got introduced to my other co-founder, Carl Hausman, who led the robotic manipulation team at DeepMind. We got to know each other quite well. Him, Sergey, Chelsea, Brian, Kwan were looking to leave DeepMind. They finally saw the light at the end of the tunnel. Like, this is maybe finally a solvable problem. And we decided to join forces.
So something Sachin and I don't talk about much on this channel is that we're actually building a startup ourselves. We've got 30 employees, customers in the US and Australia. We've got the whole thing. And one thing that hits you, it continuously monitors your security. So when the next big enterprise customer asks, you're already good to go. Just think about where the world of tech is heading. AI companies that handle sensitive data, robotics that are entering your home and workplaces. Customers expect proof come knocking. If you're building, which is $1,000 off, Assembling a crack team of researchers with such an ambitious goal required a leader with a reputation for next-level work ethic.
Lockie has been a very close friend of many people at Thrive because we were longtime or have been longtime investors in Stripe, where Lockie was a very early employee. He was a very industrious, young engineer from down under who slept on a bunch of couches till he joined Stripe and became a really early leader there. And so we had the privilege of getting to see him become, a key part of that journey. At the same time, when we made our investment in OpenAI right before ChatGPT launched in December of 2022, one of the questions that naturally came up was, could you apply these models to robotics?
After securing funding, the physical intelligence team focused on releasing demonstrations of applied generalized robotics.
So the first release was focused on capabilities, basically demonstrating that we can get robots to do the kinds of things that have never before been possible. We started with laundry. It's not the most commercially lucrative market out there, but it's this incredible task to focus on because it encapsulates so much physical complexity. It's deformable objects, it's a complex task, fine motor skills. Side effect of being useful, that's nice, but really what makes it so great is the friction for data collection is so low. Everyone knows how to do laundry, everyone knows how to evaluate it. You can get an infinite number of laundry items out there, so it's a great test bed. Since we focused on that, what we wanted to demonstrate is that we could just get a robot to fold laundry, something that was never before possible. It's kind of like the holy grail of robotics. That was March through October. That was our first release, Pi-O.
Yep.
The second release was Pi-O 5. That was focused on generalization, showing that we could get these robots to perform well in environments that they had never been trained in. That was frankly, a pretty shocking release to us. It only took about 100 homes for the robot to generalize to the 101st as if it had been trained in that environment. We thought it could be thousands, tens of thousands, even millions. Homes are about as diverse an environment gets. Your home, I'm sure, is different to mine and to his. And then this latest release has been focused on performance, which is, okay, we can get these models to do things that have never before been possible. We can get them to generalize to environments never before possible. But if you want robots deployed at scale, they need to work very well. And that's been somewhat elusive, and it's still elusive. We haven't solved the problem. I wouldn't even say we've come close to solving the problem, but we've started to develop a recipe to drive up performance autonomously. And so this next release is showing very high levels of performance on tasks like laundry, on making coffee, on assembling packaging, and hopefully we're releasing on Tuesday.
We're probably today, 18 months into the company, where I thought we would be 3 or 4 or 5 years into the company based on how fast I thought the field was going at the time of investment. So they've moved something like 2 to 3 times faster on that front than I would have thought possible in my more optimistic expectations.
Lockie and his team believing they can solve the biggest problem in robotics is one thing. However, actually solving it requires an approach unlike traditional startups. Like, what are some of the theories you have about how we can solve physical intelligence so that we can finally make robots actually useful?
Yeah, I mean, it's the same as all deep learning. Gather very large amounts of data, design and program the algorithms that can fit that data and learn from that data, and then iterate through deployment.
And that's what's happening behind us.
That's what's happening behind us. So
Okay, so far, what are your thoughts about this?
No thoughts as to speak of. I mean, so far they haven't given much detail about exactly or the technical details of what they are building.
Yes,
Maybe I get it. It's like a somewhat a generic, not generic. I mean, it's a higher level documentary. So about the company as well.
yeah.
So they're not going in details of the robotics part. But yeah, I would be interested to know what exactly they're building, how they're progressing and stuff.
Yes, even what I was about to pause a few minutes ago, but I thought that okay, let it go and let's see if it explains something. So right now he was explaining that exact thing, which I knew, which I was about to think like essentially these are all machine learning thing. Or deep learning is kind of machine learning, which the basic thing about machine learning is that you feed more and more data, and then the whatever the curve fitting will happen uh, through all the training phase. So basically everything is that thing. So whether it's text or anything. And what they're saying is this one, that they are collecting more and more data and they're trying to build that thing. So again, the concept is also the same. Like, okay, then if you build it on a particular data, then how will it generalize to something else which is not common to that thing? Again, that is also
Mm.
that is nothing specific for to robotics, I think so, because it applies to any kind of models. Because if you're learning uh, machine learning, like even simple linear regression, or if you use Python and use sklearn, the basic things are the same. Whatever is going on here, it's just the complexity is different or the problem is different. So yes, they haven't explained a lot about the mechanisms, but let's see uh, if they say anything more. There are other interviews as well, but those are like podcast style things, so they're maybe 1 or 2 hours long. So that's why I haven't looked into them. But probably those kind of videos goes deeper into the technicalities. So continue.
Behind us is what I would
I'll
refer to
go
as the
back a little
research
bit.
engine of actually solving it requires an approach unlike traditional startups. Like, what are some of the theories you have about how we can solve physical intelligence so that we can finally make robots actually useful?
Yeah. I mean, it's the same as all deep learning. Gather very large amounts of data, design and program the algorithms that can fit that data and learn from that data, and then iterate through deployment.
And that's what's happening behind us.
That's what's happening behind us. So behind us is what I would refer to as the research engine of the company. So we have researchers, a large team of researchers. They have hypotheses. The hypotheses generally require some amount of data to be collected. And so behind us, we have folks that are collecting data predominantly here on what we refer to as static manipulators. So arms bolted to a table with leader arms that they can use to teleoperate them to do the kinds of things.
Yes, as you can say, they're teleoperating here. So in the last video,
Mm.
I talked about the three modes of collecting data or training. So this is the most, I would say, the most the simplest version of collecting data. So that's what they're doing.
that you could arms bolted to a table with leader arms that they can
But
use to teleoperate them to do the kinds of
Yeah,
things.
I have a question here. What exactly is the data here?
this movement data. I mean, okay, the thing is that again, you'll have to like the data engineering part is the technical thing. Like in what format the data will be there. They'll have to like there's a whole profession called data engineering. So this data will be in some form. The technical thing I do not know. Like for anything, like if it's a financial data, I know that okay, it's a time series data of the stock prices. If it's a genetic data, is that those kind of things. If it's a suppose sports data, it could be the win and loss of the team over the season. So even here, it could be some kind of data which I probably do not know how it is, but the data is this one. Like if you look at this thing, how should you act?
Mm.
That's the thing. But in like in digital form or in like whatever, it will probably be some Excel sheet of some numbers. That will be the data. Some matrix of their numbers. There is going to be the data here.
That you could never program robots to because they're using your physical intelligence. We collect data, we annotate that data, we featureize it, we train models, and then we evaluate the models on those same stations that we collect the data on. And through the results of that, we get a sense of did the research idea work or not. That could be a new algorithm, a new data collection strategy, new data mixtures, augmentations. It could really be anything.
Yeah.
Are you eventually going to have warehouses that have hundreds or thousands of people manipulating those robots to collect the data?
I don't think so. I mean, I think we will have larger data collection facilities than you see here. But the problem with this warehouse style data collection approach is that what you're trying to do is mimic the complexity and realism of the real world. But at the end of the day, it's just a rough approximation. The way to get the most real data is to put robots in the real world doing real things. And so I think the way we solve this problem is by figuring out how do we make robots useful enough to be deployed, go and deploy them, and use that data to make the robots better and better and better. This certainly helps. It helps bootstrap. It helps allow us to test ideas very rapidly, but I don't think it's the way to solve the problem.
After everything we'd had seen in the office, our biggest question was no longer how this works, but what could it eventually change?
I think it's very clear that we're seeing these sort of early birthing moments of generalized robotics capabilities. Now, this is probably more like a GPT-2 moment than a GPT-3, 4, 5 moment, which is to say, we see the signs of life, we see the potential, but it needs to be scaled up aggressively in order for it to become very practical and useful to every person everywhere. I think if you think about the number of jobs that humans don't want to do in the physical world, that probably tells you about how large pi can be.
Yeah, and for our audience listening, like what GPT-4 is for, the tech-based world, right?
Yeah.
You're trying to build for the robotics world.
Yeah.
If this is successful, what does the world look like in 10 years' time?
It's a question I spend a lot of time thinking about.
Yeah.
I find it extremely hard to reason through.
Yeah.
It's like somewhat unimaginable how different the world could look.
Yeah.
I think it's a very good world. Yeah, it's one that I'm very excited for. I think a pretty significant amount of the things we do in our daily lives and many people do throughout their entire lives are not necessarily enjoyable. They don't do it because they want to, they do it because they have to, and it's the most tactical things like doing your laundry and cleaning the house, but there is a very large number of things that need to be done in the world to ensure the world functions that I don't think people derive much enjoyment or meaning out of.
Yeah.
I think people derive meaning out of work, but I don't think work in the future needs to look like work did in the past. And I think in our success, we really shift a lot of the drudgerous, dangerous, unenjoyable, unmeaningful work to robots. The robotic work should go to robots. And the things that people really want to do, they should be doing. And so that's really my hope with all of this. I think there's going to be a lot of very difficult and complex situations to navigate between here and there.
Yeah.
So I think I won't continue with the video because the rest of it is mostly marketing and the promotional thing. So in terms of the technical part, they haven't mentioned much details apart from the fact that it is a deep learning model. So that video was most probably for the general audience. So you mentioned about how would the data look like. So that is what I was trying to look here. So I found a few. So I'll look at here because it's going to look pretty unreadable. Most data files are.
Yeah, my basic curiosity was how are they converting movement data of like let's say laundry, the act of folding laundry or putting laundry into the washing machine into numbers. What does the data look like?
Yes. For me, I think my guess would be like they would probably be coordinates in 3D space. The patterns of 3D coordinates that they are going through. I think that would be it. What do you think about this
That
question?
is for the movement itself, but what
Yeah.
about identifying the cloth?
Yeah, so how does the computer vision model works? I think so that would also work here. Like, uh, however, a computer vision model identifies an object, differentiates between objects.
Yeah, I mean, there's probably multiple solutions. So
Yes, like for identifying whether it's a cloth, it would have to have such kind of things, and they're mostly for the movement of the hand. That's what I can think about. Because for us, it looks very complicated, but mathematically, it's just a pattern of the movement of coordinates in 3D space. So whenever we are folding a cloth, we are folding our hands are moving in a pattern, which is very much similar, however much we do it. Since we're talking about this, let us see if there isn't a lot of data sets here. It is. search on YouTube if there's some tutorials about those kind of videos. Yes, I think so. You have to look into it. I think I don't think you'll find it very. This
Yeah, I
is Pi.
mean, they keep saying that data scarcity is the issue. I don't think we'll find it this easily.
Yes. I mean, yeah. But all from a Google point of view, you can definitely find, but I don't think whether it's openly available or not. But see, because I haven't looked into it before, I don't know what terms to search, but if I have to look at financial data series, I can find it easily because I have worked on it before. But for
Mm.
this, I do not know. But this series is made by those same company, I think, because uh, this is Pi Zero. That is what they're talking about. Pi Zero.
Yeah.
So yeah, look at this. Basically, it's so they are, I think so. This whole this series, this episode, I think so. This has multiple playlists. As you can see, they talk about the model architecture, how to fine tune. I mean, if someone wants to follow this, they can know the exact technical details about how all of this is implemented.
Mm.
So for only 4 videos. Okay. So that's one thing. But mainly what I understood was that I talked about 3 approaches, of which they're looking into the first approach. I think out of the 3 approaches, the first 2 are basically the same thing, just a little bit of variation. Instead of one, the first one is the most straightforward thing. You directly teleoperate the uh, machine. The second is instead of directly teleoperating, you put some special gloves into a human, and the human does those movement. But the third thing that I was there was about which you mentioned. You also mentioned that training in a simulated virtual environment. So yeah, I have yet to find any startups that are working on training robots using that technique. So I need to look into that. But again, if that is true, because NVIDIA themselves have also, I think so, even you have mentioned that thing on the previous video, the NVIDIA's Omniverse, I think there is the Omniverse, so where they do those kind of things. Which reminded me of another news, which I was covering on, which actually I planned to talk about today, but then I found this video and decided to talk about this. So it was about Tesla. So one of the thing, I think so, since it is already here, let me just cover it now. So as I'm writing this article now, so things that in 2025, Tesla for the first time, it was beaten by BYD as the company with the highest number of EV sales. So as you can see, the red is Tesla, the black is BYD. So far, Tesla was always ahead of BYD, but in 2025, BYD sold more EV vehicles than Tesla. So yeah, there could be many reasons behind this, but the main point was that Tesla is a highly valued company. It is very expensive. It's a very expensive company. And the justification is that, but if you look at this data, you can't find a justification. Like there's some other companies overtaking Tesla. So what's the logic? So people who follow the Tesla universe, like I would say, who are regular followers, they know that the narrative around Tesla is that they are no longer a EV company. They are now an AI and robotics company. So that is going to be their future. So even if this vehicle sales are reduced, it's not a big deal for them because they're going to be an AI company. And the massive advantage that they have is the data. That Tesla has been driving, hitting the roads for more than a decade now. I think almost 15 years. So they have a lot of driving data, which they can use to train their autonomous vehicles, which this whole paragraph is this thing. But the other thing of autonomous is the robotics part, which is Tesla's Optimus. They do not have that much data for Tesla's Optimus because they haven't been using robots for the last 15 years. So in terms of this, they do not have a lot of advantage. So it doesn't add up. Either the explanation that they could give is that okay, maybe we can train those the Optimus robots using simulations in the virtual world, like the Omniverse, or yes, NVIDIA's Omniverse. But if that logic is true, then self-driving can also be taught can be trained using virtual environments. So all the data advantage that Tesla has is not actually an advantage. Any car company can virtually train it on a similar environment. So that is what I was talking about. There are only two things could be true. Is either Tesla has a data advantage, in which case they do not have any advantage in Optimus, or it could be that Optimus could be trained in virtual environments. The but in which case they do not have any advantage in terms of driving data. So that's the, I would say, thing that doesn't add up for them. And yes, so for this one, that's the only thing I had to talk about. So any thoughts about that video or about robotics models? Can you hear me?
Hello, hello.
এতিয়া আহিছে। মই এতিয়া মোৰ ফোনটো ইউজ কৰি আছোঁ, ফোনৰ ইণ্টাৰনেট ইউজ কৰি আছোঁ। তাৰপিছত এতিয়াৰ ৱাইফাইটো ইমান ভাল নাছিলে, সেইটো কাৰণে হ'ব পাৰে। চ'
এতিয়া
এতিয়া
শুনিছানে?
এতিয়া এতিয়া শুনি পাই আছোঁ মই। এতিয়া কোৱা, কিয় ক'ব আছিল যদি।
Okay.
অ,
Yeah, so regarding the two scenarios you put, right?
yes,
Training with actual data versus training with simulation.
yeah,
I do not have the technical details, so I don't know, but I feel since this uh, training with simulation or virtual world is a new tech compared to the other one,
yes,
we do not yet know the actual efficacy of training with that. Maybe training with actual data will have it may have advantages. And in that case, it could be true that Tesla has a data advantage when it comes to self-driving cars. And maybe if you use virtual environments, you can get 90% of the way there, but maybe the 10% will require actual real world data. So, like in the video of the physical intelligence robot, also he mentioned that in order to get the data, the fastest way is to put the robot in real world situations. So that is what he mentioned. That would be the fastest way to get the most amount of data when robot is put into actual environments. So even though using simulations maybe increases the speed at which the initial amount of data is gathered, and it makes the robot 60 to 70% ready to be put into actual areas. From then on, it will be able to get even better data. So maybe that is one of the scenarios in
Yes, it
which it
could.
will progress instead of only using virtual worlds.
Yeah. I'm
It
planning to
could be a
put,
mixture of the two.
yeah, continue then I'll say.
No, that's it.
Okay. So yes, I was saying that I'm planning to put this question on Reddit on certain subreddits. Then I might get some better answers on this, or like different variations of different answers, or what people think. Can you hear me?
Yeah, yeah.
Okay. Yeah, so that was the main thing that. So actually, I actually planned to talk about all those things, but later I found that video and I decided not to talk about any of this and decided to talk about that video. But turned out that that video was not very technical, so I probably should have talked about this. But anyways, uh, I'll just talk about one more and then I'll finish it. Okay, so yes, this is also one news that I found about thinking machines. This was founded by uh, one of former OpenAI chief operations officers, I think so, Mira Murati, and it came back to my attention because some of the recent news was that some of their employees are going back to OpenAI. So, which made me think about, okay, so what are you doing right now? So I found out that they are working on this. Uh, so they've only launched only one product so far, which they have named it as Tinker. So Tinker is something that can be used to fine tune existing AI models. So fine tuning is
Mhm.
basically you have a basic model and then you fine tune it on some means the original training is already being done on the model. For example, the ChatGPT 5, it's the base model. Now, on top of the base model, you can use specific data to train it for specific use cases so that your answers are much more like specific to that area. So that's what fine tuning is.
Yeah.
So I have not still completed this, so I'm trying to write an article on this. So there are three main questions that I am trying to cover here. What is fine tuning? So since I know that, okay, Tinker is a fine-tuning model. So question number one, what is fine-tuning in simple words? So that is what we explain. So while fine-tuning, what are the costs associated with it? This is important to know because since they claim to create a tool for fine-tuning, how are they improving on the existing methods for fine-tuning? Because otherwise it's useless. Like what are even creating the product for if current methods are already fine? So what I found is that the current methods are quite costly because suppose if I'm a company, suppose maybe I'm a medical research company, biotech research company, or maybe I'm a legal company, and I'm using suppose a base model, maybe let's suppose an open source model like Meta's Llama model, and I want to fine tune it into our company specific data. I have company specific data, and I want to fine tune it. So what do I have to do as a company, as a CEO? First of all, I have to hire specific ML engineers. because this data engineering part is very difficult. So AI researchers are one thing, but data engineering that's a separate job entirely. So for them, I have to hire specific employees for that. That's cost number one. And the cost number two is I have to hire or I have to like loan GPUs, or it's called I don't know what it's called, loaning, probably hiring or leasing,
Rent.
yeah, leasing or something, GPUs from providers like maybe Google, Microsoft, or maybe like specific companies like CoreWeave. So that's another cost. That's how people normally do. But what they are doing is that you don't have to do any of those things. They've made the process easier. Is that you'll still need to have expert people, but you do not have to, first of all, you don't have to you don't have to take GPUs, you don't have to hire whatever GPUs. And the second thing, you probably don't even have to hire extra ML engineers. The AI researchers who are already working there, that's enough. They can itself do this because it's more like a better interface or the whole system they made those kind of things. So they made this process a lot easier. So what I explained is a very non-technical manner. So in technical, it is probably there's a lot of details out there, but in simple words, that's what this product is all about. I think they have their whole website. So they have written this, what, I don't know, 6 or 7 blogs on this. And on 1st of October 2025, they released their first model. So here they talk about the details of what this product is all about and also how to use and everything, all the technical details about this. But in simple words, that's all the product is all about, making the fine-tuning process a lot easier than what it is currently. And I haven't yet looked into the reasons why the people are going back to OpenAI. I don't know why it is, uh, but yes, since I'm on the process of writing it, I'll have to research, and then once I'm done, I might be able to do this. So
Yeah, so
yeah,
I have also done some fine tuning before,
okay,
and basically all the machine learning libraries already have multiple functions that can be used for fine tuning. Look, TensorFlow has some, and I forgot which library was there, but any like machine learning libraries usually have
PyTorch.
functions you can, yeah, PyTorch, you have functions already that you can use to fine tune a model. So like they mentioned parameters and such things, right? So you can change the parameters, the temperatures, etc. to fine tune it. So and of course I did it at my own machine, so I don't know the cost involved with fine tuning at a larger scale. Maybe the product there, I'm not sure what product they're providing. So from my understanding, like fine tuning, it is like a coding based thing. You have to know which variables you want to change, what other. So basically, how you want to change the weights and biases. That is what fine tuning is.
Yes.
So when a model is there, there are weights and biases of that model.
Yes.
When you change the weights and biases to whatever option you want, that is basically fine tuning. And today you have all the libraries provide all the parameters you want to freely fine tune any way you want. Maybe they are providing some kind of front end to simplify that, or I don't know if they're providing a completely new library that simplifies things.
I think
But
they've
the
also,
underlying thing is already there.
okay,
Maybe they're simplifying it for people who don't have enough technical understanding,
yeah, could be.
or maybe, yeah, but I don't know how. I mean, in terms of flexibility, the already existing methods are a lot more flexible. You can choose to fine tune any way you want. If you
Obviously,
know the technical details of the language.
so they are talking about, so if you can look at this, they said that it said that we are releasing an open source library with modern implementation to post-training methods that run on top of the Tinker API. Yes, so again, I'll have to look more into this because I only looked into it today, so even I can't.
Yeah, maybe then it could be just another option to choose in from PyTorch, TensorFlow, etc. for fine tuning.
Yeah, but also I feel like it has to be more than this because they have raised a lot of money. Like, okay, I'll show you how much money they have raised. Uh, they have raised approximately 2 billion. And the startup is valued at 12 billion. And if you're raising 2 billion just to create a Python library, so that is way too much. So there probably has to be something more to this. I'll definitely have to look more into it.
Mm.
But yes, $2 billion just for a Python library. So yeah, because they're also talking uh, through these blogs, and these are very technical blogs, so it will take a lot of time to understand those things. But anyways,
Mm.
yeah. Okay, anything else you want to say?
No.
Okay, so maybe we can end this one today.